Example 1. Find the mean of the following data. Solution. Before we apply the assumed mean method, first calculate the class mark, xi, which is given by the formula, class mark, xi, equals, lower class limit plus upper class limit, is divided by 2. So from the given table, we observe, the first class interval is 10 to 25, for which, the class interval is calculated as follows. Class mark equals, 10 plus 25, is divided by 2. This is equal to, 35 by 2. This is equal to, 17.5. Similarly, we can obtain the class mark, for the other class intervals, by using the class mark formula. But, we can also follow this shortcut method, to calculate the class interval, when the class size is same for all the class intervals. Recall that, class size for any class interval is obtained by, subtracting the lower class limit from its upper class limit. Here, we observe that the class size is same, that is, 15. So the next class mark is, obtained by adding 15, to the previous class mark, that is, 17.5. Therefore, we obtain the value as 32.5, for the class interval 25 to 40, since 17.5 plus 15 equals 32.5. Similarly, the other values are obtained by adding 15, to the previously obtained class marks, that is, we obtain, the class mark value as 47.5, for the class interval 40 to 55, since 32.5 plus 15 equals 47.5. We obtain, the class mark value as 62.5, for the class interval 55 to 70, since 47.5 plus 15 equals 62.5. We obtain, the class mark value as 77.5, for the class interval 70 to 85, since 62.5 plus 15 equals 77.5. We obtain, the class mark value as 92.5, for the class interval 85 to 100, since 77.5 plus 15 equals 92.5. After finding the class marks, let us now perform the steps of assumed mean method to calculate the mean for the given group data. Step 1. Now, let us take assumed mean, which is denoted by A, from the observation values 17.5, 32.5, 47.5, 62.5, 77.5, 92.5 are the observation values. We observe that the list contains even observations. The center value of the above given observations is considered to be 2, as the list is consisting of even observations. So, here, the assumed mean is taken as the two values, that is, A equals 47.5, A equals 62.5. Now, let us choose A equals 47.5. Step 2. The difference between A and each of the xi sigma, that is the deviation, di, is calculated as di equals xi minus A. This implies that di equals xi minus 47.5. For each xi value, the di value, and also the product of fi and di, that is, fi di value for each class interval can be found as follows. Here, xi values are 17.5, 32.5, 47.5, 62.5, 77.5, 92.5. First consider xi equals 17.5. Then di equals 17.5 minus 47.5. This is equal to minus 30. Now fi di equals 2 into minus 30, since fi equals 2, and di equals minus 30. This is equal to minus 60. Consider xi equals 32.5. di equals 32.5 minus 47.5. This is equal to minus 15. Now fi di equals 3 into minus 15, since fi equals 3, and di equals minus 15. This is equal to minus 45. Consider xi equals 47.5. Then, di equals 47.5 minus 47.5. This is equal to 0. Now fi di equals 7 into 0, since fi equals 7, and di equals 0. This is equal to 0. Consider xi equals 62.5. Then di equals 62.5 minus 47.5. This is equal to 15. Now fi di equals 6 into 15, since fi equals 6, and di equals 15. This is equal to 90. Consider xi equals 77.5. Then di equals 77.5 minus 47.5. This is equal to 30. Now fi di equals 6 into 30, since fi equals 6, and di equals 30. This is equal to 180. Consider xi equals 92.5. Then di equals 92.5 minus 47.5. This is equal to 45. Now fi di equals 6 into 45, since fi equals 6, and di equals 45. This is equal to 270. Therefore, the di sigma, and product of fi di, for each of the above xi sigma is tabulated as follows. After finding fi di, we need to find sigma fi and sigma fi di. Fi is the sum of all the frequencies, that is, sigma fi equals 2 plus 3 plus 7 plus 6 plus 6 plus 6. This is equal to 30. Similarly, sigma fi xi is the sum of the values of product of fi and xi, that is, fi di equals minus 60 plus, minus 45, plus 90 plus 180 plus 270. This is equal to 435. So, the mean is obtained as follows. X bar equals a plus, sigma fi di by sigma fi. Here, assumed mean A equals 47.5, sigma fi di equals 435, and sigma fi equals 30. Then, X bar equals 47.5 plus 435 by 30. This is equal to 47.5 plus 14.5. This is equal to 62. Therefore, the mean of the marks obtained by the students is 62, when the assumed mean is 47.5. Note, similarly for assumed mean equals 62.5, the same procedure is followed. Let sigma now learn about finding mean using step deviation method. Step deviation method. If x1, x2, x3, and so on, xn are observations, and frequencies f1, f2, f3, and so on, fn are the numerically large numbers, and class sizes are unequal, then, we consider step deviation method. So, in this method we perform the following steps. Take a center or middle value of xi as the assumed mean A. Then find the deviation, di, of all the xi sigma and the assumed mean. Find the ui by using the formula, ui equals, xi minus A, is divided by h, where h is the class size. Find the product of each ui and fi. And finally calculate the mean as, x bar equals a plus h, u bar. Let sigma see the steps in detail.